We are group 32 with the materials focus area, and we will now guide you through our tool and teach you a bit about how to conduct an LCA, understanding materials in BIM, and how they are all connected. LCA, a life cycle assessment, is often a time-consuming process, so we have tried to optimize it by making it quicker to assess different material alternatives in relation to LCA. However, we have had some difficulties with developing our tool, so we have highlighted three good to know factors to take into account when combining LCA with BIM, which we will now present.
So the first one is units. So to conduct an LCA, you must know the units that are related to the material or the system that you are analyzing. And these units are necessary to know as they should be related to the functional unit. Therefore, it is important that the units which are extracted from the IFC model are converted into the relevant unit for the chosen material. However, this is a common challenge as units can be written differently within the same model. In, for example, Blender, the units can be different for the IFC values and the BIM values. We saw that the units for the IFC values were in meters and in millimeters for the BIM values, which we thought were quite confusing. However, this was just the case for the model that we looked at, so the units could be the same if we looked at another model. And for our tool, we're using the IFC values, which are using the attribute IFC unit assignment, which establishes a set of units which will be used globally within the project if not otherwise defined, which is a definition we found by Building Smart. And the code, as you can see here, illustrates the implementation of this attribute, IFC unit assignment, and how it searches for the length unit, and this is used for converting all units into the chosen unit, which in our code is meters.
Yes, so the second factor is materials and how to extract them and how it's all related. Because as we want to calculate the GWP of these materials, we have to search for the defined IFC materials. But since the materials are often only named by the developer of the IFC file, it can be difficult to extract the materials and material properties directly from the IFC file. So the way to do it is to use the IFC associates material, which is an objectified relationship between a material definition and elements or element types to which this material definition applies, and that's also by Building Smart. Furthermore, different types of IFC parameters, as you see here, can be applied to extract different types of materials. For layered elements, for example walls, the IFC material layer set or IFC material layer set usage can be applied. In short, the first defines what layers a material buildup actually consists of, so the materials and their thickness, whereas the IFC material layer set usage defines how that layer set is applied to a building element. And for profiles, for example columns, the IFC material profile set or IFC material profile set usage can be applied. And lastly, for single materials, IFC material can be used, and for component-based elements, use the IFC material constituent set. This code for our tool identifies the materials assigned to external walls, and therefore it supports both the IFC material layer set usage and the IFC material layer set. Furthermore, it counts the number of material layers within the wall and categorizes the wall based on the number of layers, if they consist of one or more layer. Lastly, I have my materials, but what now? Because after streamlining the units and defining the materials, the GWP can be calculated. But since there is no standard for naming materials, both in terms of language, letters, numbers, etc., it becomes quite difficult to automatically map the materials to an EPD. Therefore, we decided for our code only to apply generic EPDs from Table 7 from the building regulations, which is illustrated in this code. The way we coded it makes it possible for the user to choose exactly which table 7 EPD they want to assign to their material. So this was our three main problems during the development of our tool, and we hope it gave a quick overview of what to be aware of.
Yes, and now we want to show you our developed tool. First, you run the script by running the main .py file. Then you have to choose which IFC file you want to analyze. We can choose this one. It will take some time to load, so please be patient. When the script is ready, it will list all IFC walls which are external, and therefore it will also list railings, for example. You have to identify and input which external wall type you want to analyze. This is done by inputting a number from the list. We can take 1 here. The script shows you all material layer names and calculated quantities. Then you have to assign a material to each of the material layers of your chosen wall. This is done by inserting the ID number from table 7 from BR18. So we can take a random one here and another random for the other layer. When you have assigned material for all layers, the GWP for the wall with the chosen materials are then calculated. You can now choose if you want to calculate an alternative scenario by inputting Y for yes and N for no. If you choose that yes, then you will have to assign materials again. You can calculate as many scenarios as you want. So here we would just take another random example. Yes, when you are done, please enter no, and the code will ask you if you want to export the calculated results into an Excel file. So if we choose Y, it will generate an Excel file in the same folder as your code. Thank you so much.